This video is a brief overview of a topic you covered in elementary school, the topic of angles. Angles are simply two rays that have come together with a common vertex. To remind you of what a ray is, a ray has a clear endpoint, and then it extends infinitely in the same direction. So, if you had one ray and you added that together with another ray, and that vertex was shared or common, now you have an angle. An angle is not the length of these rays. The angle is the opening between the rays. There are 4 different ways of classifying angles: acute, right, obtuse, and straight. You may have also learned in elementary school that angles are measured with a tool called a protractor. There are many mathematical tools that are used. For example, rulers can measure distances, but a protractor can measure the opening of an angle. For instance, if I drew an angle, here's the common vertex that they share, and here is one ray extending infinitely, and the other ray extending infinitely. And if I want to measure this opening is measured in something called degrees. And how protractors work is the vertex is placed on the line in the middle. One ray is lined up at the 0, and I'm going to see the opening of this. 10 degrees, 20 degrees, 30, 40, 50, 60, 70, 80, 90, 100, 110. It looks to be between 110 and 115. I would have to extend that a little bit further to be able to see what exactly it lands on. And it looks to be around 112 and a half, 113. There are a few ways that you would notate an angle. I'm going to call this angle angle H after Halpern. It's usually named after the point of its vertex. The angle symbol looks a lot like a less than symbol, but this is flat. It's not written downwards. It kind of looks like a slanted L. So this is how I would write angle H mathematically instead of writing the word angle H. That is the symbol for angle. Sometimes you can also see the symbol with a line through it like that to represent the angle marking right there. You might also see this notation, a lowercase m and then angle H. That means measure of angle H. So this angle, its measure is 112 degrees. And if you know how much each angle measures, then you can classify it because the classifications depend on the measures of degrees. An acute angle has degree measures that are greater than 0 degrees, but less than 90 degrees. And you may have noticed on the protractor that a 90-degree angle is straight up and down, like this, like a capital L, pretty much. That is a right angle. So examples of acute angles are something that is smaller than that L opening. Something like this, like this, like this. It is not quite 90 degrees. Even if it were 89.9 degrees, that's still an acute angle. A right angle is exactly 90 degrees. They meet perpendicular. Sometimes you see this notation, that little box. The box is a way of saying this is a 90-degree angle without it being labeled a 90-degree angle. Obtuse angles are greater than 90 degrees, but less than 180 degrees. The one that we drew on the other side, angle H, that was an obtuse angle because it was 112 approximately, and that's between 90 and 180. Plus, if 90 is straight up and down perpendicular, it's going beyond. It has more of an opening, a wider opening than a 90-degree right angle. And then a straight angle is exactly what it sounds like. It is exactly 180 degrees. It is essentially a straight line. If you think about sports, whenever anybody does a 360, for example, in basketball or in snowboarding or in ice skating or anything like that, a 360, we know, is a complete rotation around. Well, a half circle or a semicircle would be 180 and 180. That's only turning halfway around. And notice that straight line. That's the straight line of the straight angle. So that is just a basic overview of the different angle names, how they would be classified, and that their classification depends on their degree measures. Also, there's an algebra connection that you can now make. You'll notice that with a right angle and a straight angle, the degrees are equal to a specific set amount. That is an example of how equations are factoring into the picture, because equations had one specific answer. Inequalities, though, had a multitude of answers. And you'll notice that with acute and obtuse, there are many degree measures that would fit that classification. Anything above 0, even if you had a super precise protractor, it could be 0.1 degree, which would essentially look like hardly no opening at all. Or it could be up to 89.999, just not exactly 90 degrees. The same would be true of obtuse. This is something that you can print from Google Classroom, or it's something that you can save into your drive to have as notes and as reference. And it's also something that you could recreate on scratch paper or notebook paper. And this overview will serve us as we begin our geometry unit.